Okay, a real quick take on Chapter 1 and 2 practice test. It's supposed to say practice right there. Whatever. Perform the indicator operations real quick. The idea would be g of -2 minus h of -2. We're going to -2 both of these things and minus them. So that's 2 times -2 minus 2 for the g part. That's what is that? -4 take away 2 is -6. And then h of -2. H of -2 is -2 in there, so that's -2 squared plus of -2. And we'll just square that out. That's +4 plus -2, so that ends up being a regular 2. By the time it's all said and done, now we have g of -2 is -6. H of -2 was 2. And then we're minusing them, so that's -6. Take away 2, I'm getting -8 there. On number 2, a quick take, we would say h of t minus g of t. We're just shooting t's in there, but they're already functions of t, so it's not really doing anything, so we'll just minus them as they are. So we have -t plus 1, minusing, 4t plus 2. Minusing that. Minus them. And then we'll just put the like terms together. It's -t minus a 4t is -5t. And then this is a +1 minus of that 2. Remember that minus is distributive, or you could distribute it as a -1, but that's more like a -2 now. So it's a +1 and a -2 makes -1. That's what I'm getting there. If we had this one, we have f minus g again, but of n over 2. So these ones are a little bit more intense. We got to shoot n over 2 into each one of these as we minus them. And so f minus g still looks like it looks, but then we have to get n over 2 into each one of it. So you can do that. Put the n over 2 in place of the n's either before or after you put the functions together. And so f minus g would look like 4n minus 3 take away of the other one, the g1. So it's n3 plus 5n2. If we're taking it away, that negative distributes in here again, so that's minus n3 and a minus 5n2. There's no like terms anywhere, though, I'll notice, because this is the only n3 and that's the only n2. And so it looks like we're just kind of reordering them, and that'll be it. And so negative of n3 and minus n3, and then a minus on that 5 would be a minus 5n2. And then we have a positive 4n, and then a minus 3. Only other thing to say is now we have an n over 2 we're shooting in there. So something like that would be a negative of n over 2 to the 3 minus 5 times of n over 2 plus 4 times n over 2. Oh, wait, n over 2 squared on that 5 there. 4 times n over 2, then minus 3. Look and go there. And then we'll just got to like do some figuring here. So real quick, let's see. That negative is not part of what we plugged in. So we're not taking a negative to the third power. It'll just be sitting there. But that's n times n times n. And then 2 times 2 times 2 makes 8. Minus of 5. And then 5 times n to the second would be 5n squared over 2 times 2. 2 to the second would be 4. Plus 4 times n is 4n. And then 2, just 2, and then minus 3. Then we got to just, essentially we're going to get to the answer we need by taking this junk and making the bottoms all match. So if this were a 3 over 1, what we might do is times by things until they're all over 8. And so maybe I'll take you that far real quick. So looking like, let's see here, if we wanted to do the 8's thing, this is already over 8, so I'm looking at negative n3 over 8. Then the 4, I'd have to double it, so times 2 times 2. So that's minus of 10n squared over 8 plus 4 over 2. So the 2, I'd have to times it by 4. So then this times 4 would be 16n over 8. And then minus, that's just a 1, so times that by 8. So times 8 would be 24 over 8. All that stuff put together then, it's just a bunch of junk over 8, and so I mean, imagine that I just wrote it as 1 fraction over 8 or something, and that's kind of where we would go with the rest of that. And then, let's see. Quick take on number 4. We have different parts of the domain. I'm writing this line as looks like an mx plus b thing for part of the domain. Then from x between 0 and 4, I'm doing that. it's sort of like y equals -4 and y equals -2 on these different parts. So we'll see what we can do with that. If I have x less than or equal to 0, then I'm writing the line -x minus 1. So -x minus 1, that's the line that has -1 as an intercept, and then a -1/1 slope. So that's a -1/1 slope. Oh yeah, so y-intercept. And then we have that -1/1 slope. Let's see. Oh yeah. So then I would draw, essentially this line is what I'd be drawing, is this line that's like it starts at -1 and has that down 1/1 slope, because it's a -1/1. But I can't draw that everywhere because I am at x less than or equal to 0 is the only place I get to draw that. So that's only on the left-hand side of the graph where the x's are less than or equal to 0. So I'll start from here, and I know what direction to draw, so I'll go that way. But I don't get to actually go down 1/1 because that's drawn into the wrong part of the graph. Now from x between 0 and 4 non-inclusive, we have that the y value is -4. So that looks something like the y value being -1, 2, 3, 4. And I'm just going from here to there with that because that's from x's between 0 and 4. Then my y value is down at -4, and I'll put open circles on those because I don't have equal signs. And then for any x value that's greater than or equal to 4, so this is from 4 beyond, from 4 to the right, my y value will be -2. So then my y value is -1, -2, and that's for any x value from 4 beyond. Looking something like this, I guess. On number 5, we have, it looks like a translation going on. So just remember what this means. That's down 2. And then, as we say in class, that means -3 is the new 0. New 0, or whatever, because -3 plus 3 makes 0. So then we'd say, well, it's an x squared looking graph, but I am at -3 is the new 0, and then I'm down 2 before I get to start. I'm not timesing anything in front, so I'm looking at doing the standard over 1, up 1, over 1, up 1, and then kind of curve it up from there. On the next deal, number 6, we have a bit of a translation and a dilation or something, or compression, I don't know what they call it. So then, let's see here. This thing has no up and down movement. There's no plus or minus out here, so there's nothing there. There's no up or down, but I do have a new 0. -1 is the new 0. New 0. So we'll go -1, that's the new 0. And then from here, I'm just over -1. I don't go up or down any, but I have a 1/2 timesing with this deal. And so remember what that means for us is we're going to say when I go over 1, I don't go up 1. I go up only what I'm timesing by. So I go over 1 and I'm up only a half a step. Then over to the left, I'm only up a half step. So that'll give this a different shape, a little bit more gradual. It doesn't grow quite as fast, Let's see, what else? This one, we have a 1/3 times of radical x, and so remember, radical x normally graphs out something like the square root of 1 is 1, the square root of 2, 3, 4 is 2, the square root of 9 is 3, and so we're like something like this, I guess. I don't know, just somewhere around there. This one is like that, but it's only times 1/3, so that's going to be something a little bit like not as extreme. When you're doing that, essentially we're just saying, well, it's like the usual one, but this one will only grow 1/3 as fast. So instead of being at 1, I'm at 1/3 of 1. And I'm at 1/3 as tall here, and I'm at 1/3 as tall there. Everywhere you go, this is 1/3 as tall as the usual graph. Let me pause this while that plane goes by. I don't know if you can hear the airplanes. Unpause. Now, we have g of x equals -x. So remember on the test, if we have a negative on the inside timesing, that's going to flip us left and right. So instead of like this, we'll have a square root function going out to the left. Whereas if I had just a tip on that, if you see something like this on the test, but it has a negative on the outside, remember stuff on the outside of the function is more up and down related. So instead of like this, it'll be graphing downstairs, And so remember that with a radical x or with anything else, if you put a negative on the inside, it's a left and right flip over the y-axis. If you put a negative on the outside, that's an up and down flip reflecting over the x-axis. And so kind of like we're looking at this one this time, but it could be like that next time. We'll see, something like that. And you can pair them with other transformations as well, of course. And so here we have an absolute value function. You might remember something about the behavior of those is this weird V-looking thing. with like a 1/1 slope unless we do something else wise. But this is, it's got a new 0. And so new 0 is positive 3. And so positive 3 minus 3 is 0. So we'll go positive 3 is what it takes to absolute value of 0. And then from there, we're just doing the usual absolute value thing, because I'm not seeing anything timesing it to make it a different shape. And so we just got absolute value moved over to positive 3. Number 10, we have to approximate the intervals where each function is increasing or decreasing, and decreasing, whatever. So this one, remember, as the timeline goes by, we're always reading across the page left to right. It's a little timeline here. And so we're saying the function looks like this. It's going up for a while, then down, then up again, then down. And so let's talk about increasing intervals. Increasing, where it's increasing would be, it starts out increasing. And so this one is increasing from forever. It seems like, remember, it doesn't go straight down. This is one of those that's gradually going down and out. So it's from forever on the left, we'll call it negative infinity, over and down. And it's increasing forever here until about right there. And so if we're talking, remember, we're talking about in terms of x values here, the domain, not so much the range right now. And so we're just talking about x values, the intervals on which this function is increasing. And so this is from negative infinity on the left all the way until about right there, negative 2. It looks like, nope, that's negative 1 is the x value. So we'll say I'm increasing from negative infinity to negative 1. Notice, of course, we're not including the negative 1 because it's not increasing or decreasing the x, it's turning around. Then I'm decreasing for a while, and we'll talk about that later. And then we'll increase, actually, let's just talk about that now. Then we're decreasing there. Something is missing. Don't tell anybody. Okay, decrease, good. It's decreasing from that negative 1 to basically 0, the middle of the graph. And so from that negative 1 to 0, we're decreasing, so we can mention that. Negative 1 to 0, we're decreasing. Then we're bending back up from that 0 part to the positive 1. That's an increase. So we'll say, let's union this up. Union, what was it? 0 to 1 positive is increasing. And then finally, from positive 1 till forever, this thing is decreasing. And so decreasing down, down, down forever. That one is going to say union. Here comes another airplane. Union from 1 till infinity. Giddy up. Okay, number 11. Sketch the graph here. So this one is in standard form. It's a quadratic. Doing the way we did in class, we might say, well, if nothing else, we have old 0. If I plug in 0, 0 squared plus 8 times 0, then plus 12, I get a 12 out. I want to find a new 0 so that when I can plug in some other number, I'll also get a 12 out. And so we did this thing where we were like looking at just the first two terms, and we'll figure out how to zero that and still have a 12 come out of it. And so we'll keep the plus 12, and this will be somehow we'll figure this out. And so x and, between these two, I have an x I can take out of both as a common factor, and then x times x plus 8 is what's left over, and that helps us figure out what the new 0 is. Old 0 is 0, but if I put a negative 8 in here, negative 8 plus 8 makes a 0 there. And then 0 times anything will be 0, plus 12 will be 12. And so negative 8 is another way for us to get a 12 out of it. So now we have two dots we can draw already. We have 0, 12, which is way up here, which is off the graph. And then we have negative 8, 12, negative 8, also up 12. So we're way up there. But importantly for us, we're going to find the vertex between the two dots. So vertex will be found between them. So this one is at 0, this one's at negative 8. Halfway to negative 8, we'll find our vertex, and that's at negative 4. So we'll put our little ghost line here, little dotted line, the axis of symmetry. Going down here, that's at negative 4, and we know our vertex is going to be there. And so we'll say vertex, that's at negative 4. It's 4 steps to the left because it's halfway between the dots. And that's the x value. And so if I have an x and I want to figure out the y value, we'll shoot it in there. And so negative 4 shot into the function, that's going to be, let's see here, squared and 8 times it. And so let's see here, that'll be negative 4 squared plus something 8 times negative 4. and then plus 12, looking good. Whatever that is, 16 minus 32 plus 12, so that's negative 16 plus 12. I'm getting negative 4 as well. So that y value in this case also ended up being negative 4. So we said we plugged in a negative 4, we got out for the y value negative 4, and that's enough to give us a vertex. So here we go. That vertex, we knew it was 4 steps to the left because it was between the two dots. Now it's also at negative 4 steps down, negative 4, and then we'll connect the dots. Looking good. Something like that is a little bit funny looking. You know, you can always do the whole 1 and 1 thing if it, whatever, who cares. Anyway, it's something like that. The vertex is at negative 4, negative 4. So here, number 12. Similar idea with number 12. This one has a 0 there. It's a plus 0, so it's not as interesting. But whatever, it makes it a little bit weirder. It says, more than that though, okay, so we're supposed to graph the thing. We're also supposed to list the x-intercepts where we cross the x-axis. And so, let's see about that. If I were to draw this thing, we have, first off, if I plug in a 0, I get out a 0 because there was a plus nothing at the end of it after the linear term. And then I'm looking for new 0, and let's see how that goes. If I take an x out of these first two terms, then it's x minus 2 and then plus 0. That'll be good because then I can tell that positive 2 is what it takes to make another 0. 2 minus 2 will be 0 also. So this will be 2, and that'll give me the other 0. And so this is kind of convenient because we can tell what the x-intercepts are right away. That's interesting. And then let's see here, 0, 0 is one of them, and then 2, 0 is 1, 2, 0. And then we're just, we'll find the vertex in between the two, like on the last one. That would be a positive 1, and so we'll plug in for the vertex. We'll have a positive 1. There's an airplane going. I don't know if you can hear him. Maybe we should talk about that. Anyway, so then there's a 1, and then we'll plug the 1 into the function. That'll be 1 squared minus 2 times 1 plus nothing, so that's 1 squared minus 2 times 1 minus 2 times 1. 1 squared is 1 minus 2 times 1 is 2, so that's 1 take away 2, that's negative 1. So we have a vertex at negative 1, which we kind of could have predicted. And so now we have this parabola kind of taking shape here. We have a graph of it. If they ask us for the x-intercepts, we can actually already see them. So you could really even just right now say, well, I found the intercepts. This is the x-intercept and the other x-intercept, and that's a y-intercept. It's a weird graph. Well, I guess it's good enough for now. Now in numbers 13 and 14, we have solving inequalities. So different with takes on this. What I might suggest is let's figure out where this equals 0. We are supposed to figure out what x values make this less than or equal to 0. So I'm going to start out by equaling at 0, and then we'll do some test points to figure out what the heck about what makes it less versus what is more than 0. So quick take, we would be like x minus 2, 0, negative 2x plus 5, 0. Let's figure out where we're equal to 0. So that's at x equals 2, and if you solve this out, that's minus 5 divided by 2, negative. That'd be negative over a negative, so that's a positive 5 halves, or positive 2.5. Oh, sorry about the focus there. It was getting blurry for a second, huh? Okay, now, maybe on the number line we could look at that. We have at positive, here's the 0, right? Or whatever, who cares about that? We'll just put here's 2. That's an x value where my equation is, or my inequality, whatever, where all of this mass, this expression is equal to 0. And then again at 2.5, just right after it, we're equal to 0. What we don't know is if I plug in numbers like 3 and, like 1 and 0 and negative 1 and stuff to the left of this, I mean, is that going to be stuff that I plug in that makes this all less than 0 or greater than 0? We don't know. So we'll say I'm equal to 0 here and I'm equal to 0 here. So that covers the equal to part. But the less than part is guesswork right now. And so one of the techniques we'll do is we'll just start guessing numbers. And so a number over here to the left of 2 would be like 1. A number in between the two of them, between 2 and 2.5, we could do just like 2.1, I guess, or 2.25 or something. And then something bigger than 2.5. Something on the other side of the number line of 2.5 would be like a 3. I guess we could do a 3. Sorry, yeah, you didn't see that. It's 2.1. And we could do like a 3 would be bigger than 2.5. And we'll just test them all into the original junk here and see which ones end up being greater than 0 and which ones are less, you know? So let's see. Testing at 1. So let's try it. Try 1. And we'll try that in the original expression here. That's x minus 2 times negative 2x plus 5. So x minus 2 times negative 2x plus 5. If we're putting a 1 in there, that's 1 minus 2. And negative 2 times 1 plus 5. And let's just see if that's greater than or equal to 0. Let's see here. 1 minus 2 is negative. And then negative 2 times 1 is negative 2 plus 5. So that's positive 3. If I times those, I get a negative. That's negative 3. So this is, I don't think you actually need the is, but whatever, for emphasis, is less than 0. So when I try a 1, I get less than 0. So what that means is things that are to the left of 2 actually work for this expression to be less than 0. So over here, we're looking good. I'm going to go ahead and shade over here things that are less than or equal to 0. That part will work. Probably, I'm guessing, because of the nature of this mess, this part probably won't, and then this part probably will. So let's try them real quick. 2.1, that sounds awful. I'm going to avoid that. So let's do a 3. Let's try a 3. Try a 3. And then we'll do the same thing. 3 minus 2. And then times of negative 2 times 3 plus 5. And we'll just see how that works. 3 minus 2 is 1, and then negative 2 times 3 is negative 6 plus 5 is negative 1. And indeed, that is less than 0, because 1 times negative 1 is negative 1, is less than 0. So when we tried a 3, it ended up less than 0 as well, which is what we were looking for, less than 0. So on the 3 part, which is over to the right of 2.5, these numbers seem to do what we want. And then you try the 2.1, and it won't work, and pretend like I did that. And so then it looks like we have ourselves a solution set. Anything from negative infinity all the way to 2 works. So we'll say negative